Good morning, class. We are looking at exam 4 review, covering chapter 4, application of differentiation, and chapter 5, integrals, 6.1, areas between the curves. And now for the first part, we cover 4.7, optimization problems, 4.8, Newton's method. So that's what we are covering for example. Again, I want to remind you of the pledge. I pledge on my honor that I will neither give nor receive unauthorized assistance during the exam or this exam or any other exam. In other words, when you take the exam, you take the exam on your own. I can't emphasize this enough. Differentiation formulas, we start with the definition. Some limits, definition of an E, basic differentiation formulas such as the power rule, trigonometric functions, product and quotient rules, chain rule. This is the extended power rule from the power rule when we get to g of x to the power of n, the derivative following the chain rule would be n g of x to the power of n minus 1 g prime of x. Exponential functions always itself. Then by the chain rule, you tag along, for example, k here or g prime here, and by the logarithmic rule, n and b if the base is not e, logarithmic formats of their derivatives, inverse trigonometric functions. If you go from P to Q, the distance of delta x or dx or BP, that's the run. The rise along the curve is delta y, f of x plus delta x minus f of x, or simply this distance. The rise along the tangent line is this distance of AB dy, which is f prime of x dx. Linearization refers to finding the tangent line of the function. Now, optimization, 4.7. So there are several examples I want to look at, and I'm going to do one of them for you. These are examples of optimizations. For example, we want to find two numbers whose sum is 54 and whose product is a maximum. First and foremost, anytime we have to draw a setting, we must. If we don't need it, so be it. And we have to define our variables, in this case, numbers, let's say x and y. Okay. So the objective is to maximize the product x times y, and the constraint is that their sum x plus y is 54. This is the limiting factor, if you will. If 5400 pi inch squared of metal is used to construct a cylindrical storage drum, what is the maximum possible volume? So we should know, here's the shape, and the volume is pi r squared h for a cylindrical shape. And we want to maximize that. So that is our objective. But subject to what? 5400 pi inch squared of metal. So you need the area of the base, which is in the form of a circle, pi r squared, and you have two of them, the top and the bottom. So 2 times that. Then around it, if you cut this open, looks like a rectangle with the height on one side and the circumference of the base, 2 pi r on the other side, so 2 pi r h. So subject to constraint s equals 2 pi r squared plus 2 pi r h, and it's supposed to be 5400 pi inch squared. And of course, you take it from there. Another example that we're going to look at right now from A to Z. A farmer has 2400 feet of fencing and wants to fence off a rectangular field that borders a straight river, and that's the key. He needs no fence along the river. What are the dimensions of the field that has the largest area? So in other words, you draw the setting, okay? X represents the width, Y represents the length. So the objective is the largest area. So the area is the width, X times the length, Y. So you want to maximize the area. The limiting factor would be 2400 feet of fencing. So the perimeter is normally 2 times the width, 2 times x, plus 2 times the length, 2 times y. So 2x plus 2y normally. but it borders a straight river. So on this side, we don't need anything. So it's subject to 2x plus only 1y equals 2400. A is a function of two variables, x and y. To make it a function of one variable, you're going to solve for y here, and you put it in there. And now you want to maximize A as a function of x, which is x times 2400 minus 2x. Now, it is extremely important to write the domain. The domain is from 0 to 1200. Y is that. First of all, x represents dimension, so it must be positive. Secondly, if you set this one equal to 0, x becomes 1200. If you pick a number larger than 1200, this becomes negative. With this one, the product is negative, and so the area is negative. You can't have. Okay. Now, why is this important? We have an open interval of 0 to 1200. So you have to write the domain. Because the first or second derivative test, dt, derivative test, for absolute extrema is as follows. A local extremum is an absolute one if it is the one and only one extremum in an open interval. Meaning, you go through the process, you do the first or second derivative test, and it tells you it's a local max or local mean. If your interval is an open interval and there is only one of those critical points, it's just one of them, local becomes absolute. So in this case, A prime is 2400x minus. So A of x you distribute is 2400x minus 2x squared, and A prime is 2400 minus 4x. You set this equal to 0 because you're looking for a critical point. It results in one critical point, x equals 600. So you have an open interval, you have one critical point. You have to figure out whether it's max or mean. And all you have to do, the easiest way is to go with A double prime, which is -4. Now, the second derivative test says plug in, but this is independent of x. So x is any value makes no difference. A double prime is always negative. Negative means concave down, and concave down means maximum because it looks like that. So the maximum occurs when x equals 600. And again, because there is an open interval and one critical point, this is not only local, it's also absolute max at x equals 600. So you put this here, subtract it from 2400, divide by 2, okay? And 2x plus y is 2400. Y becomes, so you put it here, I mean 2 times x, and then y becomes 1200. So the maximum area is the product of the two numbers, 720,000 square feet. A quick recap. So I looked at several examples and I did one of them. The objective for this question, first you do the drawing, you define your variables, the width is x, the length is y. You want to maximize the area is x times y. And then the parameter is 2x plus 2y normally, but again, this side borders a straight river, doesn't need anything. So 2x plus 2y changes to 2x plus 1y equals 2400. And then you take it from there. A box with a square base and open top must have a volume of 32,000 cubic centimeters. Find the dimensions that minimizes the amount of material used. First, I want to remind you of some information from algebra geometry. This is a rectangular solid. The width, the length, the height is also called a prism. The volume is the width times the length times the height. SA, surface area, 2 times the width times the length plus the height times the length plus height times the width. Because if you look at, for example, the one facing us, the area is the length times the height. You have the one facing us and the one behind it, 2 of them. The one on the side is the width times the height. On the right side and on the left side, we have 2 of them. The bottom, the area is the length times the width. And we have 2 of them because it's the bottom and the top. That's why we have this number 2. If all sides are identical, we call it a cube, in which case the volume is s cubed, the surface area is 6s squared. Now, in this case, it's a square base. So x by x by h. The objective, okay, when I find the dimension that will minimize the amount of material used. Okay, so because the base is square, so x times h is one face, so surrounding it is 4. So x times h, 4 of it. The bottom is x squared. The top is x squared, normally plus 2x squared. Normally plus 2x squared. But because it's open top, the top is not covered, only 1x squared. So the objective is to minimize the surface area of 4xh plus, again, 1x squared. Why not 2x squared? The bottom is covered, but the top is not because it's an open top. The volume is supposed to be 32,000. So the volume is the width times the length times the height. X times h. So the volume is x squared h equals 32,000. S, the objective function, is a function of x and h. We're going to solve for h in this one and put it into S. This way we make S a function of x only. X cancels out the exponent. We get 4 times 32,000, which is 128,000 divided by x plus x squared. All right, and we want to get it ready for the next step, which is differentiation. So we are going to rewrite this as 128,000 x to the power minus 1 plus x squared, and x represents dimension, so must be positive. In other words, we have an open interval of 0 to infinity. We look for critical points by differentiating. So S prime, so I'm going to use this one to differentiate. S prime is this times this, negative 128,000 x to the power minus 2 and 2x. To handle this, we are going to write it in the following manner. We're going to get rid of this and put it down here. We take a common denominator is x squared. So this is minus 120,000. This becomes 2x times x squared, 2x cubed. A fraction is 0 if the top is 0. A fraction is undefined if the bottom is 0. If the bottom is 0, x is 0, it's not part of the domain. So put the numerator equal to 0. And to solve that, I'm going to write 2x cubed is 128k, x cubed is 64k or 64,000. So take a cube root, this becomes x, this becomes 4, 3 zeros go down to 1. So CP x equals 40. We have an open interval with one critical point. So this will be an absolute. Max or mean, we don't know yet. What do? The first or second derivative test. First derivative test requires a sign graph. Second doesn't. So we're going to go with S double prime. And I'm going to go with this. I'm going to erase my work. And I'm going to differentiate. This is easier. Negative times negative, positive 256,000 x to the power minus 3 plus 2. The second derivative test says plug in the critical point and find out if it's positive or negative. That's all. So 256,000. So S double prime of 40 is 256,000 divided by 40 cubed plus 2. Now, even if you don't evaluate it, you should know this is positive plus 2 is even more positive, which makes it concave up. And that's really the key. Concave up means minimum. Why? Because it looks like this. So it's the minimum at x equals 40. So now you can find the rest of them. X squared h is 32,000. So this is 40 squared, 1600, divide 32,000 by it, h becomes 20. And so the dimensions are 40 by 40 by 20. We are done. That's all they were asking. However, if they asked, what is that minimum surface area? You're going to say 4 times x, which is 40, times h, which is 20, plus x squared, 40 squared. When you do the math, you end up with 4,800 square centimeters. What is the minimum distance between the parabolas? Y equals x squared plus 1 and y equals x minus x squared. I'm assuming everybody can graph parabolas. This one, of course, is y equals x squared, shoot it up by 1. This one, you have to find the vertex x equals minus b over 2a, plug in, and then it opens down, and you can find the intercepts. So you can graph it. That is the assumption. I mean, for the sake of argument, even if you use a graphing calculator to speed up for a case like that, because it's not about graphing, it's about optimization. Okay, so we want to find the minimum distance. So somewhere there is a minimum distance, which is a 2 points having the same x coordinates. So if this one has x coordinate as x, then the y coordinate is x squared plus 1. For the blue one, for the green one, should be x and then x minus x squared. And the distance that we are looking for is this red distance, which is the vertical distance. And let's call it v of x, which is the y coordinate of the top, x squared plus 1, minus the y squared of the bottom, which is x minus x squared. We're going to simplify this by distributing minus x plus x squared. So these two give us 2x squared, and I'm going to put it in order, minus x plus 1. And since x can be any number, we don't know where this is. We just picked a couple of points, okay? But it's a vertical distance for sure. That would be the shortest distance. And because we don't know what x is, actually it would be our real numbers from negative to positive infinity, which is again an open interval. So let's differentiate. For x minus 1. Since we want a critical point, we are going to set this equal to 0, and clearly the answer is 1/4. Now, so we have an open interval, we have one critical point, and this will be either local max or mean, and because there's only one of them, it's absolute. Now, the question is, which one is it? We don't know. And how do we check it? Either by the first or the second derivative test, it's up to you. obviously I would choose the second because V double prime is just a number and it's always positive. In other words, even if I plug this in, because that's really the idea, it makes no difference. Any number that you have here, this will remain as 4, which is positive, which makes it concave up, looking like that, which makes it a minimum. So the minimum occurs at x equals 1/4. What is the absolute minimum? We just plug it in. Instead of that, we're going to go with the easy one and we plug it in there. One over 16 times 2 is 1/8. Minus 1/4 is 2/8. Plus 1 is 8/8. The answer is 7/8, which means the minimum distance between the two is 7/8 and whatever the units that, it's not given at, of course, x equals 1/4. By the way, if you need to figure out the y for each one, you can plug in if they ask you. A cylinder is inscribed in a cone with a height h and a base radius r. Find the largest possible volume of such a cylinder. First and foremost, this may or may not be given to you. If it's not given to you, you have to come up with the drawing. You should know the shape of a cone. You should know the shape of a cylinder, and it's inside this. It's inscribed in a cone, and the cone has a height h and radius r. Those are fixed and we can't change them. So this radius is the radius of the base of the cone, or it can't be changed. That's a fixed number, and so is the height. But the cylindrical shape can change. Okay, let me just, for example, draw another one. I mean, it could be this one. Okay, or maybe this one. So the cylinder can change, but it has to be inscribed, has to be inside. And clearly, and I'm going to erase my work, and clearly, everybody, the cylinder has some sort of a radius which is somewhere between 0 and r. It's important to understand it can't be 0, because if it's 0, there is no cylindrical shape, and it can't be r, it has to be less than that. But it changes accordingly. So here's the cone. The height is fixed at h. The radius of the base is fixed at r. The cylinder is inscribed, and we want one of those. There are infinitely many of them we can put in, but the one that we want is the one with the largest possible volume. So let's define some variables. If we say this distance is x, this distance is y, remember, first, this in general is the radius of the cylinder that changes. This is the height of the cylinder that changes. We should know the volume, the largest possible. We know the formula for the volume is pi r squared h. We should know that. And in order to make life easy, we are going to say this distance is x, meaning r, we're going to represent it with x. And then the height is also a variable. See, the radius is a variable, the height is variable. The height is the difference between the height of the cone and this distance we called y. So h minus y. In other words, the volume is pi x squared times h minus y. We made it a function of x and y. You can keep it as r squared h if you want. But it is important to know that there is a relationship between them and lowercase h and lowercase r that are fixed. They can't be changed. That's why you have to make a certain change. So if you look at the right portion, it's a triangular shape in this format, and it's a right triangle. So this distance is y, this distance is x, this distance is lowercase r. This is the base of the cone, and this is the height of the cone. So we can use similar figures, everybody, and say, for example, x from the smaller one, r from this from the larger one, y from the smaller one, h from the larger triangle. So we can see that. Cross product. Y times r is x times h, and if you divide by r, you get y. So y is hx over r, and that's exactly what we are going to do. We are going to replace the y. And why do we do that? The volume is a function of two variables, x and y. We want to make it a function of one variable. So that's what we do. So this is pi h x squared. This is pi h r over r x cubed. Just multiply them. And let me erase my work so it doesn't interfere with what we do. And as I mentioned, x must be between 0 and r. Take a look. The radius of the base of a cylinder can't be 0, has to be larger than 0, otherwise there is no cylinder. And it has to be less than r, which is fixed, which is the radius of a cone, otherwise it's not going to fit in there. So we are going to differentiate. So to differentiate, starting with this one, pi h times 2x minus pi h over r times 3x squared. I want you to see that pi h is a coefficient, is a number, okay? So you differentiate x squared. Minus pi h over r is the same thing. It's a coefficient, it's a multiplier, it's a coefficient, it's a constant. So x cubed, 3x squared. And now, because eventually we want to set this equal to 0, we are going to factor what we can. Pi h and x is in common. If I take pi h x, this one and this one out, this one gives me 2. Okay. If I take this one and one of this one out, I get 3x over r with a negative. So I'm factoring pi hx out. I hope everybody's okay with that, because I'm looking for critical points and I'm going to set them equal to 0. So when I set v prime equal to 0, I get either x equal to 0 or 2 minus 3x over r equal to 0, or 2 equals 3x over r. And all you have to do multiply those both sides by r over 3. So this obviously becomes x, and the other one becomes 2/3 r. So there are two answers. And we already said x is between 0 and r, so therefore it can't be 0. So 0 is out. So we have an open interval of 0 to r, and we have one critical point. So this when it is a maximum, is an absolute maximum. When it's a minimum, is an absolute minimum. Which one is it? We don't know. We have to figure it out by the first or the second derivative test. And I'm going to go with the second derivative test, v double prime. I'm going to erase my work. So v prime, now v double prime. So I'm going to differentiate this one, pi h times 2, in other words, 2 pi h, minus pi h over r times 6x. So I hope you see that this is 2 pi h minus 6 pi h over r x. That is v double prime. And the second derivative test says evaluate it at the critical point. The critical point was 2/3 r, evaluated. In other words, plug it in and observe if it's positive or negative. So let's plug in. So this is 2 pi h, this is minus 6 pi h times 2. So let's just simplify this one, cancels this one. And this one cancels this one and becomes 2. So you're looking at 2 pi h minus 4 pi h, which is negative 2 pi h. Pi and h are positive, negative makes it negative. This is always negative. Means what? Concave down means what? Maximum. So let me erase my work. So the maximum occurs when x is 2/3 r. So find the largest possible volume. We found it when x equals 2/3 r. Now, what is the volume? Plug in to the volume formula. Probably this one. Pi h squared minus pi h over rx cubed. You plug in, or you can plug it into this format. Either way. So pi h times x, 2/3 r squared, 1 minus x 2/3 r divided by r, which is 2/3. So let's just make sure we understand what happened here. So I'm going to replace the x with 2/3 r, so to the power of 2, 1 minus x over r. If you divide this one by r, you get 2/3, which gives you 1/3. This is 4/9 r squared. So everybody, we have 4/9 pi squared times pi h times 1/3. 1/3 and 4/9, the product is 4/27 pi r squared h. So again, I'm showing you how to arrive at the answers. You should have no problem evaluating it. It's fairly simple. Section 4.8, Newton's method. Consider function as it crosses the x-axis, the root. Newton noticed a tangent line close to the root crosses the x-axis nearby. So what is the tangent line intersection? Let me explain what happens here. If you look at this curve, everybody, it has several intercepts. If you look at one of them, for example, this one, what Newton's noticed, if you draw a tangent line the tangent line also has a root, this one. Now, the blue one is the x-intercept for the function. The red one is the x-intercept for the tangent line. Are they the same? Absolutely not. But he noticed they are close. So he said, okay, here's what we are going to do. We are going to come up with the tangent line, this tangent line. So he's going to calculate the tangent line. Y minus y1 equals m times x minus x of 1. Y1 is f of x of 1, m is f prime of x of 1, and x of 1 is just x of 1. So he's going to look at this point x of 1 and come up with the equation of a tangent line. Now, he's not going to even simplify that. Then he's going to set y equal to 0. When you set this equal to 0, you're looking for the x-intercept of the tangent line. So he finds the x-intercept of the tangent line. So if you set y equal to 0, and the left side divided by f prime becomes x minus x of 1, and so x is x of 1, this moves to the other side, minus f of x of 1, this is minus everybody, over f prime of x of 1. So with this process, this is really the tangent line and set y equal to 0. This finds this point, which is the x-intercept of a tangent line, not the curve. Now use that point as a second and usually better estimate for the root of the function. Okay. And draw a tangent line then and there. So now x sub 2. So at x sub 2, you draw a tangent line. Take a look. If I draw a tangent line here, it's even closer to the actual one if you draw a tangent line here. So x sub 2 is x sub 1 minus f of x sub 1 over f prime of x sub 1. X sub 3 would be x sub 2 minus f of x sub 2 over f prime of x sub 2. So repeated application of this process is called Newton's method. And it's x sub n plus 1 equals x sub n minus f of x sub n over f prime of x sub n. I'm going to go over this concept one more time to make sure we understood what happened. Again, to recap, consider a function as it crosses the x-axis, which is called the root, the x-intercept, the 0 of the function. Okay, so here's the function, and here's the root. Okay, let me make it very large. This is what we are looking for, okay? Newton noticed that tangent line close to the root. So if you have a tangent line close to the root, crosses the x-axis nearby. So this tangent line crosses where? Here. Is this the same as this one? No, but this is close. That's the idea. So notice that tangent line close to the root crosses the x-axis nearby. Tangent line intersection, and we go with the equation y minus y1 equals m times x minus x of 1. We find the equation of a tangent line, and we set y equal to 0. And we get this one. That's it. Okay. And we repeat this process. So take a look at what happens next. The next one, everybody. So here's the tangent line. And here's the x-intercept of the tangent line. So at this point, now we're going to draw a tangent line. Take a look. So this is the first one. Look at the second one. right here. We draw a tangent line. So the first one is the blue one, and then it's the green one. Look at the green one. So if we call this x sub 1, we call this x sub 2. Again, x sub 2 is the same as this point, no, but definitely closer than x sub 1 to that. That's the concept, everybody. So we repeat that. As we repeat this over here, you have the curve, the tangent line, okay? This is way too far. From the actual x-intercept. Then at this point, you draw a tangent line. Look at this one now. This new, so you draw up a tangent line here. This point is a lot closer to that. And then now at this point, it's even closer. And the idea is the repeated process will give you the root. So there are equations, for example, we can't solve. Okay, there are equations we can't solve, and we use one method is Newton's method. Okay, class? All right, let's look at a very simple example to get something out of this. We want to calculate 3 iteration of Newton's method to approximate the zero of this function, f of x equals x squared minus 2. And we want to use the first one, x sub 1 equals 1. And since they want 3, so we want to go with x sub 2, x sub 3, and x sub 4. So we want 3 more. That's what they are asking everybody. So the very first thing is because x sub n plus 1 is x sub n minus f of x sub n over f prime of x sub n, we want to find the derivative. So f of x is x squared minus 2, f prime must be 2x. So we should find that. By the way, the graph of y equals x squared is a parabola. X squared minus 2 comes down, and it looks like that. X sub 1 equals 1. So this is the location. X sub 1 equals 1. And this is the point. We can draw a tangent line, and we can find the equation of a tangent line, right? As we draw the tangent line, notice what happens. It hits it somewhere here along the x-axis. So the x-intercept for the red line, which is a tangent line, is here. The root is here. And as you can see, we started from somewhere which was this far, and now this one is closer. That's the idea, everybody. And so having said that, if x sub n plus 1 has this formula, and we have x sub 1, we're going to write x sub 2 is x sub 1 minus f of x sub 1 over f prime of x sub 1. So this is the point. And we write this formula. So x sub 2 is x sub 1 minus f of x sub 1, f of 1 over f prime of x sub 1. So 1 minus f of 1, 1 squared minus 2, f prime of 1, 2 times 1. So obviously this is 1 minus 2, negative 1 over 2. So we get plus 1/2, 1, and 1/2, or 1.5. So the point is we found x sub 2. So x sub 1, this is x sub 2. Now, same thing, x sub 3 is x sub 2 minus f of x sub 2 over f prime of x sub 2. So this is x sub 2 equals 1.5. This is the line. And now x sub 3 is x sub 2 minus f of x sub 2 over f prime of x sub 2. So let's plug in. We're going to replace x sub 2 with 1.5. So we get 1.5 minus f of 1.5, 1.5 squared. So this is 1.5 squared minus 2. This is 2 times 1.5. And the bottom becomes obviously 3. This is 2.25. Minus 2 is 0.25. So 1.5 minus 0.25 divided by 3 with a bunch of decimals, we get 1.416667. X sub 4. X sub 4 is x sub 3 minus f of x sub 3 over f prime of x sub 3. Okay. So clearly, it gets very tedious, as you can see, because the number is very involved. So first of all, let me erase my board. So at this point, you can use a calculator to evaluate this, minus 2, this one 2 times that, and it gives you this answer. Now, because it does get involved, I put a little programming for you there, okay? So I'm going to explain that as we go through the next one. This wasn't too bad. Obviously, this was easy to calculate. This wasn't too bad either. And this, when you do the Newton's method, you have to have two things. First and foremost, what is f of x? What is f prime of x? Then you have to write either the general formula or just write x sub 2 with the formula evaluated, x sub 3 with the formula and evaluated, and then the rest of it, if you have a bunch of them to go, as it is the case here, for example, then you can use a program that is mentioned. So I'm going to go over that quickly. Use Newton's method to approximate the 8th root of 500 to 8 decimal places. I have the general format and I have this programming. I'm going to explain it in a moment. First and foremost, I need to know what is my function, what is f prime of x. So I'm going to set this equal to x. So let x represent this number. If I raise both sides to the power of 8, I get x to the power of 8 equals 500. If I bring it to the same side, x to the power of 8 minus 500 is 0, and I'm going to call it f of x. So think about this. In order to solve this, I can find the x-intercept for this function. That's the idea. And that's what Newton's method works. So if I find the x-intercept of this function, it's the same. So having said that, I need to differentiate and I get f prime of x equals 8x to the power of 7. And so I'm going to write this for f of x and f prime of x. So x sub n plus 1 is x sub n minus x sub n to the power of 8 minus 500. This is f of x sub n, or 8x sub n to the power of 7. Now, I have defined my variable. I have come up with f of x. I've come up with f prime of x. I've shown x sub n, and I'm going to show work for a couple of them. First, I have to decide where to start because they didn't give me the starting point. So because 2 to the power of 8 is 256, or 8 root of 256 is 2, 3 to the power of 8 is 65, 61, or 8 root of 65, 61 is 3. I'm going to start with either 2 or 3 or somewhere in between. You can use 2, you can use 3, you can use 2.5, makes no difference whatsoever. I'm going to start with 2. So I'm going to use this and come up with x sub 2 because I have decided to go with 2 for x sub 1. So x sub 2, therefore is x sub 1 minus x sub 1 to the power of 8 minus 500 over 8 x sub 1 to the power of 7. So 2 minus 2 to the power of 8 minus 500, 8 times 2 to the power of 7. Two minus 2 to the power of 8 minus 500 is negative 244. And this is 24 because it's 2 cubed, this becomes 2 to the power of 10. And when x sub 1 equals to 2, x sub 2 becomes, and we write a bunch of decimals. Remember, we want to approximate this to 8 decimals. So how do we do that? We are going to repeat until 8 decimals are identical. And I hope you see that. If I want to calculate x sub 3, it's very tedious. That's why we go with the programming. So number 1, you are going to put y1 equals f of x and y2 equals f prime of x. So a graphing calculator, y1 is x to the power of 8 minus 500, y2 is 8x to the power of 6. Then the next step, number 3, x sub 1 stored in x. Whatever your x sub 1 is, in this case 2, we want to store it in x. Then we use this formula. How do you use this formula for this one? You're going to write x minus, so x minus f of x over f prime. So x minus y1 over y2 stored in x. Take a look. X minus y1 over y2 stored in x. Look at this number. This is what we have here. Okay, everybody. So this is this one. Now what do? Just all you have to do, press enter. So when I press enter, I see that, okay, these are different, this is getting better. So you see the number of decimals, completely different. Now the first 2 are the same, the first 3 are the same. So it's getting better, but we want 8. So do it again. When you do it again, notice what happens here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 are identical. This is when you stop and you write, this is the answer. And of course, because you want to stop at 7, next to it is 6, it goes up to 8, and you write the 8 root of 500 must be this number. You can try it with your calculator, you see that it's correct. But the process is using the Newton's method as explained here. So it can find those. Another example would be, we want to use the Newton method to approximate the positive root for this. This is not a type of equation we can solve. So first, you can sort of guesstimate by graphing. So you can graph the left side, y equals 3 sine x. Graph the right side, y equals x, the line through the origin, and those are easy graphs. You can graph both of it, even from the memory, because you know, just sine x and then multiplied by 3. So this one, instead of pi over 2, 1 is pi over 2, 3. Okay. And so we want, okay, the positive root. That means the intersection of the two. So we want this one. I hope you understand this is equivalent to what we just did here. And so if you want that point, your function would be to bring those two to the same side and do the Newton's method on that. To do the Newton's method, I need to differentiate. I get 3 cosine x minus 1. And I'm going to write this x sub n plus 1 is x sub n minus f of x sub n over f prime of x sub n. This is f of x, this is f prime. So I'm going to write it in this fashion. And I'm going to write x sub 2 equals x sub 1 minus 3 sine x sub 1 minus x sub 1 over 3 cosine x sub 1 minus 1. And the question is, okay, what is x sub 1? So I hope, again, this is an easy graph. You should recognize, because we want the positive root, we start with 2. If we want the negative root, or we want both of them, we have to do this 2 times. Once you start with this number, the second one you start with negative 2. So if you want both of them, you have to do this process 2 times. Well, you've done most of it already anyways. So now, that means x sub 2 is x sub 1, which is 2, minus 3 sine of x sub 2 minus 2 over 3 cosine of 2 minus 1. And 2 means 2 radians, everybody. So you put the calculator in a radian mode, you plug in, you get the answer. Of course, definitely tedious. Now you're going to use the program. So we're going to put y1 equals f of x and y2 equals f prime. So y1 is 3 sine x minus x, and y2 is 3 cosine x minus 1. Then we're going to store the first number 2 into x, and then x minus y1 over y2 into x, and get those numbers. And remember what we want. We want a root, but even if they don't say 6 decimals, you have to figure out with the number of decimals, they should be the same. So this number and this number are different, so not good. Press enter again. But just for the sake of argument, x sub 3 is this number, 2.27959. 4, the 4 changes to 5 because next to it is 8. Okay. And if you press it again a couple of times, you notice 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, they are identical. If you stop at the 6, 1, 2, next to it is 3 here. Okay. But this one next to it is 6. You're going to go with this one and bring it up to 3, because x sub 4 and x sub 5 eventually result. And this is 8, by the way. 8 makes it 3. So x sub 4 is 2.2788863. They agree with each other up to 6 decimals. And that's your answer, everybody.